Hello, today we're going to talk about density curves and relative standing within a data set. Let's start off with an example. We have these data points from a test. Let's pretend it's a statistics test. And Jenny's score is that bright red one, the 86. And we want to see how did she perform relative to her peers. So just like in chapter one, the first thing you would always want to do if you just got a random data set is graph it and see what it looks like. Do your socks and see shape, outlier, center, spread, see if there's anything weird going on. So I did that here with a stem and leaf plot, and this data looks fairly symmetric. And you can see the Jenny score, it's the 86 near the bottom. There's don't appear to be any outliers, and uh, there's no multimodal peaks. It just looks like a nice symmetric curve. Also, if you do a data analysis with your calculator or your computer output, we can see here we got the mean, the median, min, max, Q1, Q3. The mean and the median being the same is confirmation of the symmetry of our data. Because if those are the same, it means your data is symmetric. We also have the standard deviation, which we will be using in a couple slides. So we see she's above average. We want to know how above average is Jenny. So we are going to use a standardized value called the Z-score. Now the Z-score is going to become very important to you over the course of this course. And the formula is you take the X value you're interested in, subtract the mean, and divide by the standard deviation. You will see on your formula sheet, sometimes it's written with these symbols. And to get you familiar with these symbols, mean is mu, standard deviation is the sigma. All right, so let's do this with Jenny's score. We have the mean from the computer output and the standard deviation. So how above average was she? We plug in the values into our formula, 86 minus the mean over the standard deviation. Plug that into the calculator and you get 0.99. So she is approximately one standard deviation above the mean. If this were a negative number, that would mean she was below the mean. So depending on what your x value is here, you can get positive and negative. Negative just means you're below the mean. Positive means you're above the mean. All right. One use of z-scores is you could compare two different values. And we're going to compare Jenny's performance on that statistics test to a chemistry test and see which one she did better on relative to her peers. So we already calculated the statistics. Now if we plug in the chemistry test where she got an 82 and the mean was 76 and the standard deviation was 4, we can then compare which one she did better in. So if you want to try it yourself, just pause and then come back and you can see the answer. All right, so the z-score for the chemistry test is 1.5. So relative to her peers, she did better on the chemistry than the statistics test. Even though she got a higher score on the statistics test, apparently everybody else did too. All right. Just to go back to one previous thing we talked about in chapter one that is related to z-scores when we get to figuring out percentages based on z-scores is percentiles. And just to review, because this is also another measure of relative standing, the definition of a percentile is the percent of operations equal to or below a value you're interested in. So like if we wanted to know what percentile Jenny was, we take the 86 count and count down and put it over how many total observations there were. This definition leads to also the median is 50th percentile. Q1, quarter one, hopefully this is common sense, would be 25th. Q3 would be 75th. And if we wanted to do Jenny's, if you take this and count down, it is 22 out of 25 scores are less than or equal to 86. So she is the 88th percentile. So that is another way of seeing the relative standing of her with respect to her peers. If we had all the chemistry data, we could do the same thing and figure that out. All right, on to a little bit different, but these will all come together, is the density curve. It is the idealized representation of your data. The area underneath the density curve is always 1, and therefore it represents the percentage of data under the curve. So it's 100% because it's equal to 1. And density curves, you can have them symmetric, you can have them skewed, you can have them uniform. It just depends what your data looks like. And just like we talked about before, if your median and mean are in the center, they're equal to each other, then you're symmetric. If your mean is greater than your median, then you're skewed right. If your mean is less than your median, then you're skewed left. All right, so that finishes up chapter 2.1. And in 2.2, we will go into the normal curve.